All right. All right. All right. So we're looking at another way to factor. If you remember, with factoring, we have x. If we have something like this, x squared plus bx plus c, okay? What we want is we want two numbers whose product is c and whose sum is b. That's really what we're looking for. Okay, now let me do this example. I think we did it last time, but I just feel better going through it again. All right. Anyway, so what we have then is we have x squared minus 9x plus 20, okay? Here. So again, we want to factor this, right? So we want two numbers whose product is 20, and the sum has to be negative 9. Okay, now you might be thinking, what about 10 times 2? That should be a 20, not 10. Let me fix that. Okay. So that's we want 10 and 2, is that going to work? Well, no, right? The product is definitely 20, but the sum of 10 and 2 is not negative 9. So those are not the two numbers we're going to want to use. Okay, what about 5 and 4? I mean, you might think 5 and 4 will work because 5 times 4 is 20. But 5 plus 4 is not negative 9, it's 9. So unfortunately, 5 and 4 are not going to work. But it looks like we're almost there, right? Namely, what we want to use instead of 5 and 4, because we want the sum to be negative 9, we want to use negative 5 and negative 4, right? That's going to work. The product is still 20 by our sap and sun rules, okay? And negative 5 plus negative 4 is negative 9. So we found the two numbers. All right, big deal. You might be thinking, how does that help us? Well, we can now factor this. Namely, as you'll see, this is going to become x minus 5 times x minus 4. X minus 5, x minus 4. X minus 5, x minus 4. So we have factored this, as you can see. And just as a check, as you can see here, we can factor this. I mean, excuse me, just as a check, what am I saying? As a check, right? If we were to multiply this, which is what I'm doing here, we indeed get what we started with. So this factorization is correct. And that's good. That's what we wanted. Okay. Okay, so that's a good example. Someone has a question. Okay.
Something I kind of observed maybe. Like with the constant term being plus 20, does that mean, so when the constant terms are positive, does that mean the two numbers have to be the same sign? They're either both positive or both negative?
Exactly, yeah.
Okay.
That's right. Very good. Very good. Right, so that's something else you could remember also, everyone, that if the constant term is positive, both numbers have to have the same sign. They're both negative or they're both positive. Okay? That is another way to remember also. So I don't know why I didn't mention that. Very good. So
I have another question.
Okay.
Do we have to show the check every time?
No.
Okay.
I'm just doing the check just to show you, like, I mean, it's a good idea to check, but I'm not going to require you to check. So.
Okay.
Okay. Good.
Thank you.
You're welcome. Good question. Any other questions? Okay. All right, so that's this example. I did this one with the other class. So I think it'd be good to do it here too, even though it's technically, I guess I listed it as a backup example, but still good to do. Okay, notice here, right, that we don't have this initially, right? We have 3 terms, and it's degree 2. That's true. However, the leading coefficient here is not 1. but here it's 1. Okay, does that mean we can't factor the way we just did? Well, let's see if we can find out. Let's see if we could just determine what the greatest common monomial factor is. I know on the slide I wrote it out already, but if we were to factor that out, that might. Okay, so what would the greatest common monomial factor be? Well, notice that since there's a non-zero constant term, that tells us not every term has a variable. So in this GCF here, this m has to be 0, and that's why I have it here. Also, 2 itself is a factor of itself of 24 and 40. Well, that tells you the greatest common factor among the coefficients and the constant term has to be 2. I mean, you list the factors of 24 and 40 if you want to, but what's nice is we don't have to. Since 2 is a factor of 24 and 40, 2 has to be the b over here, the greatest common factor of the coefficients and the constant term. So that tells us our GCF here is 2, so we can factor that out. I mean, essentially, we have a common, well, let me not say that. Okay, so we're going to factor out 2, as you can see. So doing so, right, remember how you factor it out. You put the 2 in front, but you have to divide to see what's remaining. So we have 2. We're going to divide by 2 as well, and that's the same as dividing into each term, as you can see. Here in the first quotient, the 2's cancel. That's how we get x squared. Here, 24x over 2, that gives us 12x. 40 over 2 is 20. So I did post these as well. So that's what we get here. Yeah?
Can I give the final answer?
Not yet. Almost there. Thanks, though.
Okay.
That's okay. But now we have to factor. So we did factor out 2, but notice now we have this, right? And this we can factor what's in parentheses, right? Because we have 3 terms, degree 2, and it's the leading coefficient is 1. So if we want to factor this, right, again, we need 2 numbers whose product is 20. The sum has to be 12. So so we're looking for 2 numbers whose product is 20. The sum is 12, right? And so as you can see here already, 10 and 2 are going to work. Okay, so 10 and 2 do work. So because of that, we get this thing is equal to x plus 10 times x plus 2. And all together, the final answer is 2 times x plus 10 times x plus 2. I threw a check in there as well. You know, it's up to you. I mean, it's good to check, but if you don't, that's fine. But again, all together, we get this. So even though you may not have this initially, you can still obtain it sometimes, you know, by maybe first factoring out the GCF. Then, as in this example, you might have this. So this is just one technique of factoring. Is it going to work for every polynomial? Well, no, but it's a technique that's useful. Okay, so now what I want to do is I want to share something else with you guys. Let me just get to that. So there's a worksheet here that I'm going to share the first page with. And you won't do all of them, but you could do some of them. Again, you can zoom in by going to Viewer Controls and zooming in. Let me do that. Okay. So what I want now is I want everyone to work on 1, 2, 3, and 4. You know, just take 5 minutes. Then we'll go through it together.